Imagine the sky turning a threatening shade of green, the wind picks up, a deafening roar fills the air, and a menacing funnel descends from the heavens. This is the terrifying spectacle of a tornado. These formidable forces of nature, rotating columns of air that can rip through landscapes and obliterate everything in their path, are a testament to the raw power of our planet's weather systems. They strike fear, awe, and fascination in equal measure, often becoming the central characters in dramatic weather tales. But what are tornadoes really? How do they form? And why do they seem to favor certain regions over others? Why does the Midwest often seem to be at the center of the storm? Today, we're diving into the whirlwind world of tornadoes, the weather phenomenon that has both terrified and fascinated us for centuries. In the diverse sphere of tornadoes, they are not all cast from the same mold. Their ferocity, the wreckage they bring about, and their wind velocities can differ in extremes. To categorize these tumultuous phenomena of nature, we employ something termed as the Fujita scale. This scale, a tribute to its originator, Dr. Tetsuya Fujita, is employed to gauge the intensity of a tornado by scrutinizing the devastation left in its trail, post its departure. The scale extends an F0 associated with wind speeds of 40 to 72 miles per hour and causing light damage, as seen in the 2006 London tornado. Moving up, we have F1 tornadoes with wind velocities of 73 to 112 miles per hour, causing moderate damage, such as the 1996 Stoneville-Autryville tornado. F2 tornadoes come with wind speeds of 113 to 157 miles per hour and cause significant damage, an example being the 1997 Gerald tornado. The F3 category, with wind speeds of 158 to 206 miles per hour, brings about severe damage, like the 1999 Bridge Creek Moore tornado. F4 tornadoes with wind speeds falling between 207 to 260 miles per hour cause devastating damage, such as the 2007 Greensburg tornado. Finally, the apex of the scale, F5 tornadoes, are the most destructive, with wind speeds blasting over 261 to 318 miles per hour, having the power to make houses airborne off their foundations and warp skyscrapers, as witnessed in the 1999 Oklahoma tornado. Comprehending the Fujita enables us to grasp fully the raw, destructive power and imminent danger these wind vortexes pose. What creates these formidable forces of nature? Tornadoes, these terrifying twisters that can wreak havoc in a matter of minutes, begin their life in a rather unassuming manner. It all starts with a thunderstorm, but not just any thunderstorm. We're talking about a supercell thunderstorm, the kind that is characterized by a deep, persistently rotating updraft. Now within this thunderstorm, there's a lot going on. Air is rising and falling, creating updrafts and downdrafts. But for a tornado to form, we need something special. A rotating updraft meets a rotating downdraft. This meeting of wind rotations causes the air to spin as it rises. But wait, there's more. For our tornado to take shape, there also needs to be spinning air near the ground. This happens when air from the storm sinks to the ground and spreads out in gusts. The spinning air near the ground then speeds up and moves horizontally. Here's where the magic happens. This horizontal spinning air can be tilted vertically by the force of the rising, rotating air. Imagine a spinning top that suddenly stands upright. That's what's happening here. And not all supercell thunderstorms produce tornadoes, making them all the more elusive and unpredictable. The right conditions need to align perfectly, and when they do, the result is a spinning column of air that can cause significant damage. With this deadly dance of air masses, a tornado is born, ready to unleash its fury. Tornadoes are not exclusive to the United States. They touch down all around the globe. While about 75% of the world's tornadoes occur in the US, particularly in an area known as Tornado Alley, other countries are not exempt from these powerful weather phenomena. For example, in Europe, the United Kingdom holds the record for the highest number of reported tornadoes relative to its land area. However, these tornadoes are generally much weaker than their North American counterparts. In the Southern Hemisphere, South Africa, Argentina, and Australia are all known for their tornado occurrences. In fact, Bangladesh and East India are particularly vulnerable to deadly tornadoes due to their dense populations and lack of tornado-resistant infrastructure. It's important to note that tornadoes can form anytime and anywhere that conditions are right. No matter where you are in the world, the skies above could potentially spiral into a tornado. But why is the American Midwest, or Tornado Alley, so often the stage for these violent vortexes? Well, it all comes down to a unique mix of geographical and meteorological factors. The Midwest region of the United States is like a natural stage set for the production of tornadoes. The warm, moist air from the Gulf of Mexico collides with the cold air from Canada, creating an unstable atmosphere, a crucial ingredient for tornado formation. Adding to this atmospheric instability is the presence of the Rocky Mountains to the west and the Gulf of Mexico to the south. These geographical features further contribute to the formation of tornadoes by providing the necessary lift and moisture. Another factor is the flat and dry terrain of the Midwest. This allows the air to move freely, unhindered by mountains or other terrain that could disrupt the air's rotation. Combined with the presence of jet streams, the high-speed air currents in the Earth's atmosphere, you have a recipe for tornado formation. Thunderstorms, which are often the precursors to tornadoes, are more prevalent in the Midwest. Climate change has also played a role in increasing tornado intensity in the Midwest. As our planet warms, the frequency and intensity of severe weather events like tornadoes tend to increase. It's a perfect storm of conditions, making the Midwest a prime tornado territory. Tornadoes and hurricanes are both powerful weather phenomena, but they're not the same. Let's break it down. Firstly, their formations are distinct. Tornadoes are birthed from thunderstorms, where rotating air in an updraft meets rotating air in a downdraft, causing the air to spin as it rises. On the other hand, hurricanes originate over the ocean, forming when warm, moist air rises, creating an area of low pressure beneath. Size-wise, they're worlds apart. Tornadoes are typically around a mile in diameter and last for a few minutes. Hurricanes, however, can be up to several hundred miles in diameter and last for over a week. Then comes the matter of their damage potential. While tornadoes can cause significant localized damage, the broad size of hurricanes often results in widespread destruction. In terms of lifespan, tornadoes are fleeting, with most lasting less than 10 minutes. Hurricanes conversely can rage on for over a week, wreaking havoc across vast regions. Lastly, their locations are different. Tornadoes mostly occur over land, especially in the United States, particularly in the Midwest region known as Tornado Alley. Hurricanes, however, form over warm ocean waters, typically in the Atlantic or Eastern Pacific Oceans. While they may seem similar, tornadoes and hurricanes are distinct in their destructive dances. Let's delve deeper into the infamous Tornado Alley. This ominous corridor stretches from northern Texas, across the Great Plains and into South Dakota. It's a region where warm, moist air from the Gulf of Mexico collides with cold air from Canada, creating an unstable atmosphere perfect for tornado formation. The flat, dry terrain and the presence of jet streams further contribute to this volatile mix. About 75% of the world's tornadoes occur in the United States, and Tornado Alley is their prime stage. The frequency of these spinning columns of air in this area is unrivaled, making it a hotbed for tornado activity. Tornado Alley has also been a significant player in shaping the cultural and economic landscape of the Midwest. It's a name that evokes a sense of awe and fear, a reminder of the raw and unpredictable power of nature. Tornado Alley, a name as ominous as the storms it hosts. The destructive power of tornadoes doesn't just affect landscapes and lives, it also has a significant economic impact. When tornado strikes, the immediate devastation is clear. Homes, businesses, and infrastructure are often wiped out in a matter of minutes, but the financial cost of these disasters is more than just the price tag on the damaged buildings. Let's take a look at some historical data. In May 2011, an EF5 tornado, the most destructive category on the Enhanced Fujita scale, hit Joplin, Missouri, becoming one of the deadliest and costliest in U.S. history. It caused over 8,000 buildings to be flattened, claimed 161 lives, and left over 1,000 people injured. The total cost? A $2.8 billion. But the economic impact of tornadoes isn't limited to the immediate destruction. There are also indirect costs that ripple through the economy long after the storm has passed. This includes lost production and sales from businesses that have been destroyed or disrupted, increased transportation costs due to damaged infrastructure, and decreased tourist activity in the affected areas. Ongoing utility disruptions can further hamper recovery efforts and add to the economic strain. And while the influx of insurance and disaster relief funds can stimulate economic activity through rebuilding efforts, the recovery process may not necessarily create more jobs than were lost. In fact, the type of employment may change. But it's not just about the numbers. Tornadoes have a devastating impact on human lives, uprooting people's livelihoods and severely diminishing their quality of life. The aftermath of a tornado reaches far beyond the storm itself, leaving a trail of economic upheaval in its wake. In the face of such destructive power, some brave or perhaps foolhardy individuals choose to chase these storms. We call these audacious thrill seekers storm chasers. They deliberately pursue severe weather phenomena like tornadoes and thunderstorms out of curiosity, for adventure, scientific investigation, or even media coverage. Storm chasing is not a new phenomenon. In fact, the first recognized storm chaser, David Hoadley, began his pursuits way back in 1956. Since then, the practice has gained popularity, fueled by television programs, documentaries, and the power of the internet. Despite the potential dangers, these individuals, often hobbyists, spend a significant amount of time learning about meteorology and severe weather prediction. The process involves extensive driving and forecasting, and their observations can be crucial in reporting to authorities. While some storm chasers are paid for their work, most incur expenses rather than making a profit. It's a testament to the raw magnetic allure of Mother Nature's most tempestuous fits of fury. In the world of weather, tornadoes are a force to be both feared and, for some, fervently followed. Tornadoes, with their immense power and destructive potential, continue to captivate and terrify us. As we've journeyed through their formation, witnessed their frequency in the Midwest, and compared them to hurricanes, we've seen that these spiraling storms are a force to be reckoned with. They're unpredictable, forming when rotating air in an updraft meets rotating air in a downdraft within a thunderstorm, and most commonly during supercell thunderstorms. Their international presence is undeniable, yet their prominence in the United States, particularly Tornado Alley, is unmatched. The collision of warm, moist air from the Gulf of Mexico with cold air from Canada creates an unstable atmosphere, ideal for tornado formation. These twisters have a significant economic impact, from the destruction of assets to lost production, sales, and ongoing utility disruptions. Yet there are those who dare to chase these storms, tracking them for scientific investigation, media coverage, and even the sheer thrill of it. As we continue to study these incredible weather phenomena, we gain not only knowledge, but also a greater respect for the power of nature itself. Stay safe, and keep your eyes on the skies.